All right, next we're going to take a minute and determine how we can sketch a polynomial by hand without using our graphing calculator. All right, so what we're going to do is we're going to go through this step by step. Now, your sketch is going to be kind of an estimate. It's not going to be perfect, but it's going to be the best that you can do without actually using your calculator or tons of points to graph it. All right, so the first thing you're going to do is you're going to take a look at your polynomial function, and you're going to determine the end behavior. Now, what I would suggest doing is drawing a quick sketch of your graph. It does not need to be perfect, based on the degree and the leading coefficient. All right, so first of all, let's make sure this is in standard form and order. So highest to lowest exponent. How hot's your exponent? It's a degree of 3, 2, 1, exponent of 0. So we're in standard form. So we know that this one has a degree of 3 because the highest exponent is 3. And the leading coefficient here is a positive 1. So what that means is if I'm going to sketch this, it's going to start low, doesn't matter what the middle looks like, and end high. So you start at the bottom and go up. So your end behavior, you know that you're going to start here, end here. We don't know what the middle is going to look like yet. Okay, so your end behavior is as x approaches infinity. So as x approaches infinity, so as x gets bigger and bigger, what's your graph doing? The graph, or f of x, is also going towards infinity. So we know the end over here has to go up, 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 okay? As x approaches negative infinity, what is my graph or my function doing? So as x is going to the left, what's your graph going? Down, 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 down. It's going towards negative infinity. So we know down here it's going to be pointing down. Up here, it's going to be pointing up. Now, the next thing we're going to do is factor to determine the zeros. So that's going to tell us where it's going to cross your x-axis. Okay, if you want to, you can set this equal to y or leave it as is. All right, so we're going to do this one as factoring by grouping. Okay, so we have x to the third plus 3x squared minus x minus 3. So remember, we're going to group our first two together. Let's factor out an x squared. So that becomes x plus 3. And then this one, remember your second set of parentheses has to be exactly the same as that x plus 3. So we have to factor out a negative 1. And that is going to make this x plus 3. Okay, so what's exactly the same? Exactly the same as your x plus 3. So we factor that out. Okay, and what are you left with? X squared minus 1. Now, you're not done yet. You always want to check to see here. Okay, and so you want to check to see here. X plus 3 does not factor, but x squared minus 1 is a difference of squares, and that factors into x minus 1 times x plus 1. So that's going to tell us that we actually have 3 distinct real zeros at negative 3 from this one right here, at positive 1 from this one, and at negative 1 from this one. So we have 3 distinct zeros. So that's going to tell us that we have exactly 2 turning points. Okay, so it's going to turn twice. Okay, all right, your y-intercept, that's going to be when you plug in x is equal to 0. So up here, when you plug in x is equal to 0, this becomes 0, 0, 0. That's all gone. And you just have negative 3. So it's at 0, comma, negative 3. All right, so what we're going to do, okay, is we are going to plot each of those points that we have. So first of all, we know our y-intercept is at negative 3. We know we have x-intercepts at negative 3. We know we have them at positive 1 and at negative 1. Well, now that we have a bunch of dots, how are we going to determine what exactly it's going to look like, all right? So the question is, we have all these points right here. How are we going to determine if it crosses the x-axis at each x-intercept, all right? Now, what you could do is you could plug in a value of x right here and see if it's above here or below here. Same thing here, you could plug in a value of x here to see if it's above or below, plug in a value of x to see if it's above or below. But I'm going to talk about multiplicity next, okay? And multiplicity is how many times you see each zero. So this 0 of negative 3 has a multiplicity of 1. Multiplicity of 1 means this is x plus 3 to the first power. Okay, multiplicity of 1 here. Okay, this is this x minus 1 to the first power. There's only one of them. Multiplicity of 1 means how many of those zeros do we see? This has an exponent of 1 right here. This also has a multiplicity of 1. Now, if something has an even versus an odd multiplicity, if we have a multiplicity of, say, like 1, 3, 5, 7, whatever, when we have an x-intercept, what's going to happen is your graph is going to shoot through those x-intercepts. So it goes through it, shoots through it, and keeps going, goes through it, shoots through it. If we have even multiplicity, so 2, 4, 6, 8, what happens is at that x-intercept, we have something that's called a bounce point. So that means it hits that x-intercept, bounces, and comes back up. Hits that x-intercept, bounces, and comes back up. Well, each of these are odd multiplicities, so that means we're going to shoot through that x-intercept. So how do we know how to graph this? Well, first of all, we said in our end behavior that the graph is going to start low. So we know the graph is starting low. We're hitting my x-intercept. Now, this has a multiplicity of 1, so I have to shoot through it. Now, I know I have to turn and come back down to this point. This had a multiplicity of 1, so I'm going to shoot through it. Okay, I know I have to hit that y-intercept. Okay, and at that y-intercept, I'm going to have to turn, come back up to this x-intercept. This has a multiplicity of 1 also, so I'm going to shoot through it. Now, look here. My end behavior matches end behavior matches my end behavior, and I'm good to go. Okay, so it's not perfect, but it's a really good estimate. And we said, since we have 3 different distinct zeros, no x, no squareds, no the third, whatever, we're going to have exactly 2 turning points. So here's your first turning point, up, goes down. Here's my second turning point, down, going up. Okay, so let's just talk about multiplicity for a second. So an even multiplicity means that the 0 occurs an even number of times. Okay, and what that means is that might be x minus 3 to the squared, x minus 5 to the 4th, okay, x minus 6 to the 6th, whatever. So that means this is 3, you're going to see this 2 times. This 6, you're going to see this 6 times. This 5, you're going to see this 4 times, okay? So what that's going to tell you is that even multiplicity at that 0, it's going to hit that point at that 0, bounce, think of like a trampoline, and then go back down, okay? Odd multiplicity of 1 means the 0 occurs once. Okay, so that's x minus 1, x minus 3. Notice there's no exponents here, okay? Now, the signs will change when you're crossing the 0. So what that means is this is basically like it's going to go from negative to positive. It's changing right here. It's shooting through it. So it's going to go from negative to positive. An odd multiplicity of 3 or higher is the same thing. So the 0 occurs an odd number of times. Okay, so this could be x minus 3 to the 3rd, x minus 5 to the 7th, etc. Okay, so this is when your degree is greater than or equal to 3. Okay, now the signs will change here, and there's going to be a point of inflection. Okay, so think about this. Okay, this one, it just shoots through. If it's 3 or higher, notice what's going to happen is I'm concave up, I'm going down, and I'm potentially turning and going concave up. So this could potentially be a point of inflection. Okay, so let's take a minute, and I would like you to try graphing this one on your own without a graphing calculator. And then once you're done, I want you to take a second and check your answer. All right, so let's take a minute and see what this graph is going to look like. Okay, so let's take a look at the end behavior. So let's determine the degree of my polynomial. All right, this one has an understood degree of 1. This has a degree of 2, and this has a degree of 3. So if I add these all together, this is going to tell me that this has a degree of 6. So if I would multiply this out, I'd basically be doing like negative 2x times x times x, and that would make this negative 2x to the 6. Okay, because I have this negative sign out here. This would be a positive, multiplying by a positive, multiplying by a positive, multiplying by a negative gives that a negative 2x to the 6 would be my leading coefficient. So what that's going to tell me is that I have an even degree with a negative leading coefficient. I don't care what the middle looks like for right now, but for my end behavior, it means both ends are going down. So as x approaches infinity, your function is approaching negative infinity. So going down, going down. So as x approaches negative infinity, your function is also going to approach negative infinity. Okay, so we're going to factor determine the zeros. Now, this one's actually kind of nice here because it's factored for us, right? So we just have to set each factor equal to 0. 2x minus 1 equals 0, x plus 2 equals 0, and x minus 1 equals 0. So this is going to give me x is 1/2. This is going to give me negative 2, and this is going to give me 1. Now, what I need to do here is I need to make sure I know what the multiplicities are. All right, so this has a multiplicity of 1. What that means is at this x-intercept right here, this is going to shoot through it because this is an understood exponent of 1. Right, it's going to shoot through that x-intercept. Right here, negative 2, this has a multiplicity of 2. That means it's going to bounce. It's going to hit that x-intercept, bounce, and come back down. This one at this x-intercept, it's going to shoot through it. All right, this one right here has a multiplicity of 3 because the degree is 3. Once again, okay, so that means it's going to shoot through it because it's an odd multiplicity. All right, then the last thing we need to find is the y-intercept. Okay, so what you're going to do, always do the end behavior, zeros, and your y-intercepts. Your y-intercept, you're just plugging in 0. Sorry, messed that up. Okay, so you're just plugging in 0 here. So you're going to end up with f of x. F of 0 actually equals negative 2. Sorry, I keep messing this up for some reason. 2 times 0 minus 1 plus 0 plus 2 squared times 0 minus 1 to the third, okay? And so what you can do here is you can figure this out, but once you do the math, you end up with 0, negative 4. So let's plot the points that we have. So we have x is going to be, I'm actually going to scale this so that this is 1. I'm going to go every other. negative 1, negative 2, just to give me a little bit more space here. Okay, so, and sort of same thing here. I'm going to go 1, negative 1. All right, so we have x is 1/2. So that's going to go right here. Okay, we have x is negative 2. That's going to go right here. We have x is 1. That's going to go right here, and have a y-intercept of negative 4. So I'm actually going to need to count 8. Okay, so how do I know how to graph this? Well, first of all, I know I have to start low. Okay, starting low. Once I get to negative 2, okay, I said I have a negative 2, so at there I have a multiplicity of 2, so I have to bounce. So here I have to bounce around, right? Okay, you know you have to get to that y-intercept, so follow till you get to that y-intercept. At the y-intercept, you know you have to come back up now to get to this 1/2. Once I get to the 1/2, okay, if I notice right here, multiplicity of 1 has to shoot through it. So I'm shooting through it, but I know at some point I have to turn and come back down to this one. Okay, if I turn and come back down to this one, notice, okay, because this is my 1, multiplicity of 1, turning, coming back down, shooting through, and my end behavior is going down. If you have any questions, please reach